let us go back to our historic way of learning the common numbers. Hope we all remember what is a number, a set, and the type of numbers. There are sets of numbers that are used so often that they have special names and purpose. We all know what is a natural number is. A natural number is the one that starts with 1 and goes on 2, 3, etc. There won't be 0 in there. When we add 0 to it, it is called a whole number. Adding a 0. Okay? They always call it as counting numbers. What is an integer then? Remember, integers include negative numbers, that as 0, 1 till infinity, negative 1 till infinity. Remember, there are no fractions in integers. Clear? So integers can be negative, like -1, -2, -3, -4, -5, etc. and can be positive numbers like 1, 2, 3, 4, 5, etc. It goes till infinity. And it has 0 at the center. Okay. After integers comes the rational number. You know what is a rational number? A rational number is a number that can be written as a simple fraction, that is as a ratio. What is a ratio? 3/2, 1/2. These are all ratio. 1:2 can be written as 1/2. Right? Example 1.5 is a rational number because 1.5 equal to 3/2. It can be written as a fraction. Okay, here are some more examples of rational numbers. 5, a whole number 5, is also a fraction. We can write a 5 as 5 divided by 1. Is it a rational number? Yes, a whole number is also a rational number. 1.75, it can be written as a fraction. How it can be written? 7/4. So it can, you remember the rule, rational number is a 1. A number that can be written as a simple fraction. Okay, so 7/4 is a simple fraction. Yes, 1.75. Okay, 0.0001. Is this a rational number? Yes, because you can write it as 1 divided by 1000, which gives 0.001. Is it a rational number? Yes. Then comes, let's one more example, 0.1111, etc. goes on. How can we represent this number? 1 divided by 9. If you divide this divide 1 by 9, you will get 0.1, 0.1111. It keeps on going. You know how to divide? Go and try divide and find out. So now you can represent this infinite series. These are all finite series. Look, it ends. The number of digits after the decimal point ends with two digits. Here with 3 digits. Here it keeps on going, infinite, so it doesn't end. If you divide 1 by 9, it goes on like 0.11111111, etc. Right? Is it a rational number? Yes, because it can be represented as a simple fraction like this. Let us take one more complicated root. Is square root of 2. Square root of 2. Can it be represented as any fraction? No way. You cannot represent square root of 2 as some fraction like this. Hence, square root of 2 is not a rational number. Very clear, okay? Remember, it cannot be written as a simple fraction. And there are many more such numbers. They are not rational. Such numbers are called irrational numbers. We will come to that later. What is the formal definition of a rational number? What is a rational number? More formally, we would say a rational number is a number that is expressed in the form P by Q, where P and Q are integers. Oh, we saw what is an integer, right? If not, go back and check. and q is not equal to 0. Remember, in the denominator, this is numerator. Whatever on the top is called the numerator. Whatever written on the bottom of the division symbol is called the denominator. You cannot have q as 0. Irrational number is a number that cannot be represented or written as a simple fraction, right? The decimal goes on forever without repeating. If it is repeating like what? Remember, we did like this, p by q, where 1 by 9. What we did? 0.111. The 1 repeats forever, right? If it repeats like a 0.123, 123, 123, etc., then this is also a proper rational number. But certain numbers like pi and other things is irrepeatable. Such number cannot be this thing, and it's forever. The decimal goes on without repeating such numbers. For example, like pi. Pi is an irrational number because look, it doesn't repeat here. 3.141596535897932384626433383279 goes on. So there is no pattern to the decimals, and you cannot write down a simple fraction that equals pi, even though values like 22 by 7 get close but are not right. Remember, pi is not represented. It is only just a closest possible representation. So pi is an irrational number. It is called irrational because it cannot be written as a ratio. Not because it is irrational means crazy. So what is the difference between rational and irrational? You remember once again, 9 can be written as a simple fraction. Look at this. So it is not irrational, so it is a rational number because it can be clearly represented and there is no repeating. There is an end to this, sensible end to this. Okay, but in case of square root, you see a lot of other examples. Everything ends or something repeats without any problem in the decimal area. What doesn't repeat? Square of 2. Square root of 2 doesn't repeat. Pi has a value that is not repeatable. For example, go and check it in your calculator. Square root of 2 will give what? 1.414213562337. Do you see any number repeating? So it actually goes on and on with no pattern to the numbers. When there is no pattern, it is called an irrational number. Hence, you cannot write it as a simple fraction that equals the square root of 2. So the square root of 2 is an irrational number. What are the other famous irrational numbers? Pi. Pi is the famous irrational number. Over 1 million decimal places, still there is no pattern. The first few digits look like this. These are the few and keeps going. There are, a lot of people recollecting the number pi. Euler's number, the number E. Euler's number is another famous irrational. People also calculated E. That's called Euler's number. It's not E. Okay. Lots of decimal places without any pattern showing. The first few digits look like this. Look how Euler's numbers look like. It is another number like pi. 2.71821821804590452353602874. There is another number called golden ratio. Roots etc. are also irrational numbers, like square root of 3 is irrational, square root of 99 is irrational. But square root of 4 equal to 2 and square root of 9 equal to 3, so not all roots are irrational. Don't come to a conclusion all square roots are irrational. Okay.